students, good evening all. Yesterday we started discussing about divisibility rules. Let's continue the session by discussing some other questions. So what are the basic rules which we studied is, so we just had a discussion on the divisibility rules of this. Divisibility of 2. When the number is said to be divisible by 2, number is said to be divisible by 2 if and only if the last digit is divisible. Number is said to be divisible by 2 if and only if the last digit is divisible. Divisibility with 4. A number is said to be divisible by 4 if and only if last two digits are must be divisible by 4. Last two digits must be divisible by 4. Divisibility of 8. Divisibility of 8. A number is said to be divisible by 8 if and only if last three digits must be divisible by 8. Last three digits must be divisible by 8. So I am taking some example here so that you will get a clarity. 462, is it divisible by 2 or not? Yes, it is true. So 564, is it divisible by 4 or not? Check out last two digits. Is 64 is divisible by 4? Yes. 4 2s are 4 6 are. Yes, it is divisible by 4, leaving a remainder as 0. It is must be divisible. If you observe the divisibility of 8, so 561 56024 is there. Is it divisible by 8 or not? Check out last three digits. So it is divisible. 024 is divisible by 8. Entire number is divisible. So, and you can also remember like this. 2 is nothing but 2 power 1, 4 is 2 power 2, 8 is 2 power 3. So because it is 2 power 1, to check the divisibility of 2, you can check out last one digit. Last one digit. Because 4 can be written as 2 raised to the power of 2, you can check the last two digits. If the last two digits are divisible, we can say that is divisible by 4. That is divisible by 4. So similarly, 2 power 3 is 8. Last three digits are divisible. Then we can say that number is divisible. So that's why divisibility of 2, 4, 8 will be last one digit, last two digits, and last three digits. Last one digit, last two digits, and last three digits. You can check the last one digit, two digits, and three digits. Even any power of 2, you can apply the same logic. If it is 2 power 4, you can check last four digits. Last four digits is divisible, we can say the entire number is divisible. So like that we can apply the divisibility rule for these numbers. You can check last four digits must be divisible by 4. So like that you can check the divisibility of 2, 4, 6, 8, all the powers of 2. You can check the last one digit, two digits, three digits, four digits, like that powers. Similarly, divisibility of 3, divisibility of 9 will be similar. What is divisibility of 3? Digital sum must be divisible. Digital sum must be divisible by 3. What is divisibility of 9? Digital sum must be divisible by 9. So why we are checking digital sum? So because divisibility of 3 and 9, so many times I have seen even previous repeated TCS questions where the students are getting confused in solving the questions. But we can easily solve. So we'll try to understand what is the proof behind it, and we'll try to apply the proof in order to get the divisibility. So divisibility of 3 and divisibility of 9. So 3 divisibility I already told you. So let me take or assume, let's assume a 3-digit number. Let's take a 3-digit number. What is that 3-digit number? Let's assume that the 3-digit number is ABC. So all the numbers which we are dealing with, are going to be base 10 numbers. So ABC base 10, we can write it as C into 10 raised to the power of 0 plus B into 10 raised to the power of 1 plus A into 10 raised to the power of 2. This is the expansion of the number. This is the expansion of the number. This is a 3-digit number. So if you observe the divisibility with 9, so you want to check the divisibility with 9. You want to check divisibility with 9. So to know the divisibility with 9, I am just taking this number ABC base 10 and dividing with 9. So if I divide this with 9, that means C into 10 power 0 divided by 9 plus B into 10 raised to the power of 1 divided by 9 plus A into 10 raised to the power of 2 divided by 9. What is 10 power 0? That is going to be 1. So it is C into 1 divided by 9 plus 10 power 1 is nothing but 10. 10 into B divided by 9. 10 square is 100. 100 into A divided by 9. You can go with the individual reminders here. 1 by 9 is 1. C into 1. You are going to get a remainder which is equal to C. 10 by 9 remainder is 1. 1 into B is going to be. So remainder is going to be 9 nines are 9 ones are 9 1. So it is giving a result 99. Remainder is 1. So 1 into A you are going to get a remainder as C. What is the overall your remainder you are getting? C plus B plus A. So that is the reason the divisibility of 9 is nothing but whatever the number you are having, you can take the individual digits summation. You can take the individual digits summation. So if you know that if the individual digits summation is divisible by 9, we can say that number is divisible by 9. If not, it is not divisible. So, and that is the reason, that is what we are calling in the other words, digital sum must be divisible. That is what we are calling in the other words, digital sum must be divisible. So that means, for example, if I take any number, so for example, if you take any number as 72, so what is the digital sum of 72? 72 digital sum is 7 plus 2, that is going to be 9. Is it divisible by 9? Yes, it is divisible by 9. You no need to manually check. Let me take one more example. 8, 8, 1, 9, 2, 7. Is it divisible by 9 or not is a question. What you can do, you can directly check the digital sum. 8 plus 1 plus 9 plus 2 plus 7. What is the sum of the digits we are getting? 8 plus 1 plus 9 plus 2 plus 7. What is the sum of the digits? 8 plus 1 is 9, 9 plus 9 is 18, 20, 27. 27, 2 plus 7 is 9, or otherwise directly you can check 27 is going in 9 table. We can say that entire number is divisible. So we can say this number is completely divisible by 9. So like that, any number is there. To check the divisibility with 9, what we can do is we can directly check the digital sum or sum of the digits. Digital sum or sum of the digits. For example, you have any number, if you are dividing with 9, if they are asking us to find out what is the remainder over there, then how can we find out? So reminder over there means you can directly check out what is a digit sum. What is a digital sum? See, for example, I have a number 80 divided by 9. What is a reminder? So what is a manual calculation? So 9 ones are 9 eights are 72. What is the leftover remainder? 8. Or otherwise, you can take 80 and you can find out what is the digit sum here. Digit sum is 8. We can say the remainder is going to be 8 here. We can say the remainder is going to be 8 here. So not only this, any number you take. For example, let's assume that I have a huge number 7201 is divided by 9. What is the remainder? So I won't spend much time in solving the question. 7 plus 2 plus 1. What is the sum of the digits? 10. What is 1 plus 0? 1. That is going to be the remainder. Because I am dividing with 9, I should not get a remainder which is more than 9. I should make it as a single digit number which is ranging from 1 to 9. Okay. So the remainder here is going to be 1. So like that, any number is there. In order to find out the remainder after dividing with 9, you can directly check the digital sum of the number. So for example, 5, 6, 4, 2, 1, 5. If this 5, 1 is this number is divided by 9, what is the remainder is the question. So generally what we do, what we studied in school standard is you can start with the 9 table. So 9 ones are 9 fives are 45, 9 six are 54. So we left with the 24. So 9 twos are 18, 18. So we left with a remainder of 62. 9 sevens are 63. So I am going with 9 six. So we left with 81, 9 nines and we left with 51. So 9 uh, 9 fives. So overall, what is the remainder? Remainder is going to be 6. Overall, what is the remainder? Remainder is going to be 6. So like that, we can say remainder is 6. But doing this is taking time. Instead of that, we can use another approach. What is the other approach? So other approach is 5 plus 6 plus 4 plus 2 plus 1 plus 5 plus 1. So I can check the sum of the digits. 5 plus 1 is 5 plus 6 is going to be 11. 11 plus 4, that is going to be 15. 15 plus 2, that is going to be 17. And 18. 18 plus 5 is 23. 23 plus 1, 24. What is 2 plus 4 is finally giving a remainder which is equal to 6. That itself is answer. So that's how you can proceed with the solution of the questions. So I hope you are able to get the point. So what we are doing is we are trying to check the digital sum of the number. So why I have discussed all this point is to make you to solve this type of questions. Yesterday I have shown some questions. I didn't solve those questions. This type of property based question, divisibility with 11, divisibility with 11 is important but easy. Divisibility with 8, divisibility with 9, divisibility with 3, divisibility with 90, divisibility with 11. So divisibility with 8 and 11, divisibility with 88. Can you solve this question and can you tell me what is the answer choice for the question which is available on the screen? This type of questions we are getting more in the examination, especially TCS. What is the answer, child? Very simple. The given number is 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on and so on, 300 digits, and so on, 300 digits. The question here is, when n is divided by 9, what is the remainder? N is divided by 9, what is the remainder? What is the answer, is when we divide n by 9, what is the remainder means? We can just observe 1, 2, 3, 1, 2, 3, and so on, 300 digits means 123 is a 3-digit number. Like this, how many 123s we should have? So 1, 2, 3, 300 digits means 123, 3 digits. At a time, we will be having 100 digits. So what is the remainder when we divide with 9 means we just need to check out what is the digital sum of the number. What is the digital sum of this? 123 is coming for how many times? 100 times. What is the digital sum of 123? 6. What is the digital sum of 100? 1. 6 into 1 is 6. We can say the remainder when we divide with 6 with 9 is going to be 6. Mark it as answer. Very simple. Questions are going to look like difficult, but once you understand the logic or strategy, you can feel very comfortable in solving the question. You can feel very comfortable in solving the question. Can you tell me what is the answer for this question? Similar question, but the here number is 1, 2, 3, 4, 5, 6. There is a printing mistake, only 1 times 7 is there. 6, 7, 8, 9, 10, and so on. 38, 39, 40 is the given number. The question is, when we divide with 9, what is the remainder is the question. When we divide with 9, what is the remainder is the question. So before we are proceeding with that question, let me ask a very simple question. So for example, 1, 2, 3, 4, 5. Can you tell me what is the sum of the digits? 1 to like what is the sum of the numbers which are ranging from 1 to 5? So one manual calculation we can do. 1 plus 2 is 3, 3 plus 3 is going to be 6, 6 plus 4 is going to be 10, 10 plus 5 is going to be 15. 10 plus 5 is going to be 15. We can say sum of these numbers is going to be 15. Sum is going to be 15. So if you want to find out like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 to 10 numbers are there. So what is the sum of the numbers? So 1 to 10 numbers, we can say 1 plus 9 is going to be 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 5 is 10. 40 is here, another 10, 50 plus 5, 55. So we can definitely say that sum of these numbers will be equal to 55. Sum of these numbers will be equal to 50. So we can say sum of the numbers here will be equal to 50. So this is doing a manual calculation in order to arrive the answer. So we are doing a manual calculation in order to arrive the answer. So instead of this, if you want to find out the answer in the other way, we can also use the other way. What is the other way of finding? The other way of finding is you can write 1 to 5 numbers in the reverse order. 1, 2, 3, 4, 5. 1 to 5 numbers in the reverse order. You can try to check out sum of the digits. What is the sum of the digits? 1 plus 5 is going to be 6. 4 plus 2 is going to be 6. 3 plus 3 is going to be 6. 2 plus 4 is going to be 6. 1 plus 5 is going to be 6. How many times 6 is coming? 6 is coming for 5 times. So 6 into 5 is going to indicate the sum of the two pairs. But we need the one pair summation. 6 into 5 divided by 2, that's nothing but 15. Similarly, 1 to 10 numbers, if you want to find out the summation, 1 to 10 numbers, write in the forward direction, write in the reverse direction. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After writing in the order, you can check what is the sum of the each pair. 10 plus 1, 11, 9 plus 2, 11, 8 plus 3, 11, 9, 7 plus 4, 11, 6 plus 5, 11, 5 plus 6, 11, 4 plus 7, 11, 3 plus 8, 11, 2 plus 9, everything is 11. How many times 11 is coming? 11 is coming for 10 times. 11 times 10 divided by 2 is giving a result which is equal to 55. 11 times 10 divided by 2, which is giving a result which is equal to 55. Why I am telling all these points is, there is one thing which you have to remember whenever your numbers are natural numbers. Natural numbers means you very well know the numbers which you can start counting naturally as 1, 2, 3, 4, 5, 6, so on will be treated as a natural numbers. So sum of the first n natural numbers, you can use a direct formula, the same formula we are trying to derive here. So if it is 1 to 5, instead of doing the manual calculation like this, you can directly take 5 into 6 divided by 2. That will be the summation. If it is numbers from 1 to 10, you can directly take 10 into 11 divided by 2. 10 into 11 divided by 2. Similarly, 1 to n numbers are there. 1, 2, 3, 4, and so on till n numbers are there. If you want to find out what is the sum of the digits, you can sum up all these numbers. You can directly use like 1 to n numbers, right in the reverse order, n plus 1, like that. N times n plus 1 will come, half of that will give the sum. And that is what we learned it as sigma n formula. So what is sigma n formula? Sigma n is nothing but n into n plus 1 by 2. So if it is 1 to 10, 10 into 10 plus 1, 11 by 2. If it is 1 to n, n to n, n into n plus 1 by 2. So the point which I want to tell you is, just remember sigma n. Formula of sigma n is indicating sum of first n natural numbers. That is nothing but n into n plus 1 by 2. N into n plus 1 by 2. So if the numbers are given like this, there is a number n which is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. 38, 38, 39, 40. So what is the sum of the numbers? Sum of the numbers is n into n plus 1 by 2. It is 1 to 40. So 40 into 41 divided by 2 will be the value. 40 by 2 is nothing but 20. 20 into 41 will give us a summation. That is nothing but 82 and add 1 0. 820 is going to be the sum of the numbers. Like that, any numbers are there, you can use the same similar kind of calculation in order to arrive at. Here, when we divide this number with 9, what is the remainder? What is 1 to 40 numbers? It is sigma 40. I'm trying to find out what digital sum of these numbers. Sigma 40 is nothing but 40 into 41 divided by 2. That's nothing but 20 into 41. Digital sum of 20 is 2, 41 is 5. 5 into 2, 10. 10 is nothing but 1. Answer choice must be option B. Answer choice must be option B. Similar kind of question which is given in the previous TCS paper, but question is talking about divisibility of 3. Have a glance on the question. Tell me what is the answer choice. What is a reminder when we divide with 3? So numbers are ranging from 101 to 150. The number is going to be 101, 102, 103, 104, and so on 149, 150. What is the reminder when we divide with 3? It's a huge number, but 101 to 150, I want to know some of the digits. Let me check out. Sigma 150, that's minus sigma 100. So that I'll get 101 to 150 summation. What is sigma 150? That is n into n plus 1 by 2, 150 into 151 divided by 2. Sigma 100 is nothing but 100 into 101 divided by 2. So this is nothing but 75 times 151 minus 50 times 101. What is the digital sum here? 75 digital sum is nothing but 7 plus 5 is 12. 7 plus 5 is 12. That is nothing but 3. 151 digital sum is 7. 7 into 3, 21. 21 is nothing but 3. 50 digital sum is 5. This is 2. 5 into 2, 10. Digital sum is 1. 3 minus 2 is 1 is nothing but 2. So the remainder is going to be 2. Remainder is going to be 2. You can mark the answer option B. Remainder is going to be 2. You can mark the answer choices option B. So like this, any huge numbers are there, you can use a similar kind of logic in making the answer choice. Sir, what should we do when we divide with 11? So 11 divisibility is nothing but difference of alternative digits summation should be equal to 0 or any multiplier of 11. Should be equal to 0 or any multiplier of 11. Should be equal to 0 or any multiplier of 11. So it is not only difference of alternative one digit. So alternative one digit or any odd number like 3 digits or 6 or 5 digits, any odd number, or 7 digits or 9 digits, like this. So here I am taking three digits at a time. Alternatively, 300 times 123 will come. So like 300 digits means 123 will come for 100 times. So 50 123s are in even place, 50 123s are in odd place. Difference of this is going to be 0. So we can say the remainder is going to be 0 when we divide with 11. Remainder is going to be 0 when we divide with 11. So not only difference of 1 digit, it can be 1 digit or 3 digits or 5 digits or 7 digits. Like that you can able to find out the value. So that is how you can tackle the questions which are related to reminders. Even the huge numbers are there, you no need to worry or bother about it. You can easily tackle those. Okay. So let's continue the session on Monday.